lesson 6, adding rational numbers. So we're going to add fractions. When you have pictures, you can divide each of them up into the same amount. That's one of the easiest things to do. Now these ones, we have shaded areas. The shaded areas represent how much is being taken out. So how much is being taken out over here? We have 1 over 3. How much is shaded? 1 over 3. Or sorry, not 1 over 3. Pardon me. 1 over 5. We have 5 pieces that got divided into. And how many do we have on the right? 3. That's where my 3 was coming from. 3 out of how many pieces? 5. Good. So how many shaded pieces would I have altogether? 4, right? So I could put this shaded piece way over here, and then this one here would be not shaded, and I'd have a full empty one, and I'd have 4 shaded pieces. Does that make sense? Okay. So I've got 4 out of 5 shaded. Okay? Any questions with that? No? Ringing a bell from before? Yeah, that's easy stuff from long time ago. All right. Let's take a look at these other ones. It may not be shaded very well for you guys. So these ones, it doesn't even look like they're shaded for me. So what should be shaded is this part here, all of this one, all of the second one, and just the teeny little spot on the bottom of that one. Okay, so it's wanting to know how much is shaded there. Now the first thing you got to look at is, are they divided into the same amount of pieces? That's the first thing you have to check. Because if they're not, you have to make the other divisions to make them the same amount of pieces. Okay? All right. So we have the same amount of pieces shaded here, guys? Yep, they're divided up into the same amount. So how many are shaded on the first one? Out of how many? Good. How many are shaded on the next one? 2 big ones and 1 over 4. Now, we could have also said 9 over 4 is shaded. Okay, so we could also say that's 9 over 4. So I have 4 here, that gives me 8, and 1 more is 9. Okay, does that make sense? Okay, so we're going to add those together. Now, typically when we add, we like to change it to improper fractions, unless we can see the objects. We could actually see the objects. So we could add them with this mixed number, okay? But otherwise, we do not add fractions as mixed numbers, okay? We always have to change them to impropers first. So we're actually going to use the 9 over 4. So how many pieces are shaded out of 4 over there? How many total pieces? 10 of them. Good. So I have 10 over 4 pieces shaded. Well, that's going to give me 2 and exactly 1/2. Where am I getting the 1/2 from? Where am I getting the 1/2?
That one is shaded piece, the other shaded piece.
Right, the 2 single shaded pieces. So the 2 single shaded pieces give 2 out of 4, and I know 2 out of 4 is the same thing as saying 1/2, because he ate half of it. Okay, so that's where that half is coming from. Okay, so both of these answers would be correct. Okay, both are correct. The next one, the shading should look like this. They're shaded. We have this whole one, and that whole one shaded, and this whole one shaded, and just a teeny piece. Okay, so in this case, I've got 2 whole shaded pies, or I could say 8 out of 4. Okay, do you see where I got the 8 out of 4? Yeah? 4 for each of the circles, right? Okay, let's look over here. We've got 1 and 1 over 4 shaded, or we could say, how many out of 4? Totally shaded here. 5 of them, good. Or we could say 5 out of 4 shaded. Okay, because we've got these whole numbers and there's whole pies shaded, we can actually take a look at that and we can add the 1 and then 2. So we could have 3 whole shaded pies, and then how much left over? 1 more. There's 3 left over that are not eaten yet. So we can have 3 total and 1/4 gone. Okay, so 3 and 1/4 gone. Now, if we did it by adding the improper fractions, that's these ones down here. I would add my top numbers. When you're adding the fractions, what do you know about the bottom number? It's staying the same, isn't it? It's not changing. You're not adding bottom numbers. You're only adding the top numbers. But you can only do it if what happens? You only add the tops if something is very, very certain.
If both denominators are the same.
Exactly. You have to have the bottoms, the denominators the same. Otherwise, you can't have the tops. Okay? All right. So the bottom numbers are the same. I can take my 8 and my 5, and I can get 13 out of 4. And if we change this guy, our mixed number, into a improper fraction, let's just try it. If we change it, we're going to take 3 times 4. That's going to give us 12. We add the 1. How much is that? 13, which is my top number over here. Okay? So same thing's happening. Are you catching the flow here? Yeah? Good. This should just be a review for you guys. We've been doing this for a few years. Okay, well what if you have different denominators? That means the pies are cut up into different amount of pieces. So, the first one, I've only got 3 pieces. So I've got 1 over 3 here. On the other one, I've got 1 out of 5. My bottom numbers are different. So I'm not able to add them when my bottom numbers are different. So what do I have to do? What's a good strategy? What am I going to have to do? Any ideas? Well, they already are simplified. So how am I going to add those guys? Sure.
If you multiply the first denominator by 5, you get 15. The second denominator by 3, you get 15 and so on.
Exactly. So you want to cut them into the same amount of pieces. So how's a good strategy to do that? The easiest way to do that is to take the 2 bottom numbers and just times them. If I take 3 times 5, what do I get? 15, right? So that means I can divide up all of the pies into 15 pieces. So the one that's already into 3 pieces, each of those 3 pieces I divide into 5 pieces. Okay, so I'm going to make 5 pieces out of each one of those. There's 5 pieces. There's my 5 pieces. There's 5 pieces. So now I've got 15 pieces. So if I have 15 pieces, how many are shaded now? How many are shaded over here? 5 of them, right? So on the red one, I've got 5 out of 15 pieces shaded. Okay, let's take a look at the blue one. Now the blue one already has 5. What do I have to divide each one of those? I have to divide them into 3. Good. So if I divide them into 3 pieces, each one of them, I again now have 15 pieces. Oh, I'm making them into 4 pieces. What am I doing here? Hang on.
No, that's 3 pieces.
Was it? I don't think so here. 1, 2, 3. Oh yeah, okay. Alright, that does work. There we go. So I got 15 pieces in both of them now. So how many are shaded in the blue one now? 3 of them are. Good. So I've got 3 out of 15 pieces shaded in the blue one. Now my bottom numbers are the same. Okay? We couldn't add the 1 over 3 and the 1 over 5. The bottom numbers weren't the same. Now when they're the same, we can add our top numbers. So what's my bottom number going to be? 15. Good. It doesn't change. So I'm adding my tops. 5 and 3 give me 8 out of 15 pieces. Okay? So 8 out of 15 of those are shaded. Okay? Is that making sense? Yeah? Okay. We can also do it using these kind of number lines. Okay? Now we've got number lines. These ones are kind of easy to deal with. Would you like me to put that back for you? Somebody still ready? No, we're good? Okay. So on these ones here, what are you noticing? Well, from 0 to 1, they're the same length, right? They're the same length. Both those charts are the same length. Does that make sense to you so far? Okay. They both go from 0 to 1. Make sense? Okay. Now, whenever you find an object like that where you've got 2 different pictures, what you want to do, just like we did with the pies, is you want to divide them into the same amount of pieces. So who's got the most pieces, the top one or the bottom one? The top one. So all you're going to do is divide the bottom one into the same amount of pieces. Okay? So we've got a line right here, and these middle lines add up. That means I can divide this guy into that many pieces, the same thing. Okay? So I can divide the pieces the same as that other guy's pieces. Okay? So in the first one, I've got how many? 1 over 6 shaded. Okay, in the red I still have 1 over 6. But now I changed the blue one into 6 pieces. So how many of the pieces are shaded now? 3 of them. Okay, 3 out of 6 pieces. So am I able to add those 2 now? Can I add both of them now? Yeah, you can. Because the bottom numbers are the same now. So we can take 1 and 3 is 4 out of 6. All right, are we finished?
No,
No. What's our last step? Always.
lowest terms.
Lowest terms. You must simplify. So what's a good strategy for simplifying? What are you going to do? What's a good strategy? Good. Start dividing by 2. Now, why'd you choose 2, not 4 or 6? Good. 2 goes into 4 and 6. They both divide evenly. Now, there's another strategy. Why did we choose 2 and not 3? What do you notice about these two numbers? What kinds of numbers are they? 3 doesn't go into 4, you're right. What kinds of numbers are those? They're even numbers. Good. So if they're even numbers, I have to divide by an even number. So I'm going to divide by 2. So if we divide them both by 2, we're going to get 2 out of 3. Okay? Is that making sense so far? Yeah. Perfect. Okay. Let's take a look at the next examples. This one's just showing you how to convert denominators. So what do they actually do? What we do is, like I showed you in the last one, we take the 2 bottom numbers and what do we do to them? We multiply them. Good. So what happened here? They took the 2 bottom numbers and multiplied. And that gave us our 24. Okay? Now, fractions are kind of special. They're kind of like a balance beam, but they're kind of like an up and down balance beam. So that means that whatever you do to one of the sides, meaning either the top or the bottom, whatever you do to them, you've got to do to the other one. So if I took the bottom numbers and I multiplied them, I've got to multiply top numbers by something. Do I multiply them together? No. You multiply them by the numbers that the bottom numbers multiplied by. So this 8 here multiplied by which number? The 3. So since this guy multiplied by the 3, the top is going to multiply by the 3. The 3 over here multiplied by the 8. So the 2 is going to multiply by the 8. So that's where I'm going to get 3 and 16 over here. Okay, I converted my denominators, or my numerators. Now once your numerators are changed, your bottom stays the same. All you have to do is add the top numbers. Okay? Then I look at my final answer, 19 over 24. Can that go lower? No. There's one reason. How do I know? There's a special reason. Try it.
1 is odd, 1 is even.
Okay, one's odd, one's even. Sometimes they can still divide. Yes, 19 is a prime number. Okay, so 19 is a prime number. So that means that only 1 and 19 divide into 19. So that means if the bottom number does not divide by the top number, 24 does not divide by 19, that means that's as low as it can go. Okay? Now sometimes they can divide by prime numbers. We have a whole bunch of prime numbers. 3 is a prime number. 2 is a prime number. Lots of numbers divide by 2 and 3. But here, 19 is a special kind of prime number. Okay? It's it's an odd one, absolutely. Yep. So on these questions, you have to check the bottom numbers. First thing always with fractions, check your bottom numbers. Are they the same in number 1? Yes. So we add the tops only. So we're going to get 3 over 5. Now let's check and see. Do we have to change that? Does it go lower? No, it doesn't. All right. Number 2 has a different bottom number. So what am I going to do to number 2?
Multiply it to a match given number.
Good. So you're going to multiply the bottom numbers. Okay? So when I multiply the bottom numbers, I'm going to get something over 20 plus something over 20. Does that make sense? Okay. Because 5 times 4 is 20. Now, the bottom number here, the 4 multiplied by the 5, so that means the top number, the 3, is going to multiply by the 5 as well. So 5 times 3 is 15. 5 on the bottom on the right, he multiplied by the 4 beside him. So that means the top number above the 5 is going to multiply by the 4. Okay? So now we're going to get 3 times 4 is 12. All right. Now I have the same bottom numbers, or identical, so I can add the top numbers. What do I get for my top numbers now? 27. Good. Out of 20. Can I have a number that on the top is bigger? Sure you can. Absolutely. What kind of numbers are they called? Improper fractions. Good. Now, does 27 and 20, do they have any factors in common that they can divide by? Well, one's odd, one's even. Doesn't automatically mean that they can't divide down. Sometimes they can. But will they divide down now? Not in this situation. No, they won't. Because 27, the only numbers that multiply to 27 are 1 times 27, 3 times 9. That's all. And 20 doesn't divide by any of those numbers except for 1, but we never usually consider 1 because everything divides by 1. Okay, but those other 3 numbers that make 27, they don't divide into 20. So that means I'm done. Final answer. Okay, let's take a look at number 3. Number 3, 6 times 4. Am I going to just multiply the bottom numbers? You can if you want, but do you know a different number they have in common? Something smaller? Well, 2 is a number that divides into them. You want these numbers to divide into a bigger number. So what number? Yes, they both divide into 12. Now, we could have used 24. 24 will still work. That just means we have to reduce it in the end, though. Okay? But if we choose the smallest one, we don't have to reduce as much. We reduce the number of steps we have to do. Okay? So, we're going to do it once with 12, and I'll do it once for you with 24, and we'll see how it works. So, over 12 plus something over 12. So my bottom number, what times 6 gives me 12? 2 times 6. Good. So I times the bottom by 2 to get to 12. So I'm going to times my negative 5 on top by the 2 as well. So I'm going to get negative 10 on top of that one. What do I multiply 4 by to get 12? 3. Good. So you're going to multiply him by 3. Okay. 3 times 3 is 9. Okay. Now you've got negative 10 plus 9. How big do you get? Good. Negative 1 over 12. Okay, that's our final answer. If one of your numbers is a 1, you're done. You can't go any lower. Okay? Now I'm going to do that exact same question with the number 24. Okay? I'll show you what happens when we use the number 24. So, I'll put 24 in the bottom of both. So, 6 times is by 4 to get 24. That means I have to multiply the negative 5 times 4 to give me a negative 20. That's negative 5 times 4. Okay? To get 24, the 4 times by 6, so I would take the 3 times 6. So 3 times 6 is going to give me 18. Now I'm going to take those numbers and add them. I'm going to get negative 2 over 24. But now, what will those ones do? They both divide by 2. And if I divide them both by 2, what happens? I get 1 over 12. So I get the answer quicker if I use the smallest common denominator. That's why it's called least common denominator or lowest common denominator. If you use a bigger one, you just have to reduce the fraction in the end. So there's a couple more steps. Okay, but it's the exact same thing. What do we notice on number 4? It tells us, hint, convert mixed fractions into impropers. We cannot add those unless they're in improper fractions. Okay? Okay, so we're going to change this guy to an improper fraction. So we need to take 3 times 5, and we're going to add the 2. So what's 3 times 5? 15. Plusing 2. 17 over 5. Plus my 1 over 5. How much does that give me? 18 over 5. Good. And you leave it as an improper fraction. Okay? Lowest terms, a reduced final answer, lowest terms, is never a mixed number. If you get a multiple choice question or a question on your final PAT that says which one is in simplest form, this one, or let's say the mixed number, 3 3/5, which one is the lowest terms and correct answer? The 18 over 5 is the better answer. If you circle this one, you'll get it wrong. Okay? In grade 8, you learned that mixed numbers were your lowest terms, not the impropers. In high school, we changed that around. That was just so that we flipped. In elementary, it was so that you guys could keep it more simplified for you. That's all it was, because you weren't dealing with a lot of different bottom numbers. Now we're going to complicate things and move on. And we're going to put fractions in algebra. Okay, we're going to start putting x's on top and on the bottom with numbers. That's where this is eventually going. Okay? Here's a couple for you guys to do. I want you to try these questions. Give number 5 a try first, and then I want you to do 6, 7, and 8. Here's a quick trick though. Remember, if the signs are the same on the inside, like on number 6, what happens to both those negative signs? they turn to positives. Same with number 8. The negative signs in the middle will turn to positives. The one on the outside is still negative. And on number 7, the inside ones turn positive as well. So we're still adding on these questions. Even though they look like subtracting questions, we're still adding. Okay? So you can do number 7 and number 6, but on number 5 and 8, you must turn them to impropers. Okay? Give those a try. Push pause now and play when you're ready. Okay, on the first one, we need to change them to mixed numbers before we can do any multiplying. Okay, before we change those bottom numbers, those have to be in improper fractions. And when I was walking around checking how you were doing, that was a common mistake people were doing. Is they were multiplying the bottoms first and changing the improper fractions, but forgetting to multiply their tops. So, let's change them first. You always have to change first. So 2 times 6 is 12, plus the 1 gives us 13 over 6, not 13 over 18. Over here, I've got 3 times 4 is 12, plus my 2 is 14. So 14 over 3, my bottom's still a 3. You cannot multiply anything else yet. At this point, this is where you check the bottoms now. They're different. So you've got to multiply them to be the same. So you could do a variety of different things. I could take 6 times 3 and then multiply my top numbers by the same numbers. Or I could take, multiply them the left by 2 and the right by 3 to make a common denominator of 12. Or you could go even smaller. They both divide into 6. So that means the 13 over 6 won't change. It stays the same because it already has a 6 in the bottom. From the right-hand side, I can multiply the bottom number by 2 to get a 6. Well, that means I have to do the same thing to the top. That's going to give me 28. Now you can add them. So your bottom number is going to stay a 6. Now you add your top numbers, you'll get 41. Okay? That will not reduce. It's done. Now, if you did 18, you would just have to reduce it lower. Okay? If you did 12, same thing. You'd have to reduce it lower. You divide by a couple numbers to make them lower. But your final answer will give you 41 over 6. Okay? So check your work. All right, number 6. Bottom numbers are the same already. We don't have any mixed numbers to change. Add your tops. 3 out of 5. On the bottom left, number 7. Bottom numbers are different. So if I multiply them together, I get 15. So I have something over 15 plus something over 15. Now I multiply my top numbers by the same thing I multiplied the bottom numbers by. So 3 multiplied by 5. So the 1 on top is going to multiply by 5. The 5 on the bottom on the right multiplied by 3. So the top will multiply by 3. So my new top numbers are 5 and 9. Now you can add your top numbers. So 5 and 9 give me 14. So this should give you 14 over 15. Okay, check your work. Okay, first thing on number 8 is change to improper fractions. 7 times 1. Remember, you're forgetting that negative sign till the end, and you're going to put them back on the end. So it's just 7 times 1, not negative 1. So 7 times 1 is 7, plus your 4 is 11. So you have 11 over 7. Now put that negative sign back onto the top. Okay? So you worry about the negative very end. And the one on the right, 2 times 3 is 6. Plus my top is 8, so I have plus 8 over 3. Now you can change your bottom numbers. So now I can multiply them together because nothing else multiplies to them. So 7 times 3, 21. 3 times 7, 21. Now I multiply my top numbers by what I multiplied the bottom by. 7 times by 3, so the negative 11 is going to times by 3. So I'm going to get negative 33 on the top there. 8, or the 3 times by the 7, so the 8 is going to times by 7 to give me a 56. So now you're going to add those numbers. Now remember, you're only adding the top. So you're going to type in negative 33 plus 56. 1 is a negative, 1 is a positive.
Negative 89.
Try again.
What?
Okay, so add the tops, what do we get? 23 over 21. Good job. Okay, let's look at some decimals. We're going to do the same thing we did with those other number lines. So we're going to find that first number on the number line. So 2.3. We'll count in 3 of them, 3 notches. Okay, so there's my 2.3. And I'm going to add 1.5. So I'm moving to the right. I'm adding 1.5. So if I add 1 whole, that takes me to 3.3. Now I add 5 more steps. Where should I end up at? 3.8. Good job. I should end over here at 3.8. Okay, so your answer is 3.8. What is the first thing I must do on number 2? What do you have to do on number 2? That's right, we have 2 signs in the middle that are the same. When they're the same in the middle, they change to plus signs. Okay? Alright, so the first thing I'm going to do, I'm going to find 3.1. There's my 3.1. And now I'm going to the right and I'm adding 1.8. If I add 1.8 to 3.1, where am I going to end up? Right, way over at 4.9. Right there. Okay? You guys try number 3 and then we're going to take it up together. Okay, let's see how far you got. So you're going to find 1.6. You count 3 notches or 6 notches in. 1.6. Remember, the 2 in the middle, same signs, will change to pluses. So we're adding. We're going to add 2.7. And where should we end up? At 4.3. Good. We're way over here at 4.3. Good job. Okay, now let's talk about subtracting. Subtracting is the exact same thing in the same rules as adding, okay? Same rules for adding fractions, meaning you need the same bottom number, and you change them the same way, okay? If you've got mixed numbers, they must go into improper fractions, but you want the same denominator. You want the same number on the bottom, okay? So sometimes you have to change or convert your top numbers, just like we did when we were adding. Only this time now we just subtract. Now, sometimes you're going to get signs that are different in the middle. Sometimes we get a plus and a negative in the middle. What if we get those numbers, or those signs in the middle of 2 numbers? What happens? It just exactly, they disappear and just becomes a negative. So meaning subtract. Okay? Let's give these a try. So, first thing you check, is the bottom number the same? Yes, it is. So I'm going to subtract. 2 subtract 1 is 1 over 5. Good work. All right. Now the negative signs are sitting right beside, so it's kind of hard. So what you've got now is you've actually got on top negative 3 subtract 2. That's what you've got on top. So what's negative 3 subtract 2? Negative 5 over 4. You have to visualize the number line. Where are you at? You're at negative 3, and you're going 2 more to the negative. You're going 2 more to the left. So that means you're going to be further negative on that negative line. Okay? So it's a bigger negative number. Negative 5 over 4. And that's how we leave it. They do not go any lower. Okay? You don't change it to a mixed number. Let's try C. 5 subtract 11 is? Okay, it's a negative 6. Negative 6 over 6. What do we know about negative 6 over 6? Do they divide evenly? Yeah, they do. What do they get? A negative 1. If you can solve them and simplify to a whole number or an integer, positive or negative number, you definitely do. So you're not going to leave this question as negative 6 over 6. Okay? If you did, you'd only receive a half mark because it's not fully simplified. You've got to fully simplify it by doing the dividing. Okay? All right. This one now. Now these negative signs are hard sometimes because they hide right beside the fraction line. That's why I always rewrite it and I write them a little bit above. So, negative 8 subtract 12. Okay? The bottom number is already a 3, so I know my bottom number is going to be a 3. Okay? But remember, now you're at negative 8 on the number line and you're going left further negative. You're going further negative to the negative 12 spaces more. So where do you end up? At negative 20. Good job. Now, do negative 20 and 3 have anything in common to reduce? No, they don't. They don't go any lower. Okay, let's try these ones. Again, same rules apply. we want to change our bottom numbers to be identical to the top. Okay? Or sorry, not identical to the top, but to be identical, period. So, on the first one, we're going to take the two bottom numbers and just multiply them because they don't divide into any other number smaller. So if we multiply 5 and 4, what do we get? 20. Good. So that means I'm going to take the 5 and times it by 4. I'm going to take my top number 2 and also times it by 4. So that gives me an 8 over 20. Then I do the exact same thing to the number 4 on the bottom on the right. He multiplies by the 5. So does the top, multiplies by the 5. So I'm going to get 5 over 20. And then I put my subtraction sign back in. I'm subtracting them.
3 over 20.
So we're going to get 3 over 20. Good job. Okay, 3 over 20. Will that go any lower? No. Okay, it does not go any lower. Let's do the same thing with the next letter on B. 8 times 3 is 24. So we're going to have something over 24 subtracting something over 24. Now let's convert the tops. The 8 times by 3, so the 1 is going to times by 3. So the 1 times 3 gives me a 3 for the top. On the right, times the 3 by the 8. So you're going to times the top number 2 by the 8. So 2 times 8 is 16. Now you've got 3 subtracting 16. So again, think of it in terms of money. That might help. So you have $3, but you owe someone 16. You can only pay them back $3. How much do you still owe them? $13. So we're going to get a negative 13 over 24. Now, is that going to reduce anywhere? No, that doesn't go any smaller. Okay, you guys try C and D and see how you do. Okay, so we're going to do the left-hand one. We're going to use 12 for our common denominator. You could have multiplied 6 and 4 and got 24, but then you'd have to reduce everything in the end, okay? So we're going to use the smallest one, which is 12. So I have something over 12 subtracting something over 12. Now, why is it subtracting? I see a plus negative. Yes? That's right. When you have one of each in the middle, two different ones, they turn to subtract. Okay? All right. So now I'm going to take a look and see what did I do to my bottom numbers. Well, I took the 6 and times it by 2 to get 12. So I need to times my top by 2. So I'm going to have 5 times 2 is 10, and there's a negative sign out front of here. Now on the bottom, the 4 times is by 3 to get 12. So I'm going to times my top by a 3 as well. So I'm going to get 9. So we get negative 10, subtract 9. So you're at negative 10 on the number line, and you're going further left. You owe somebody $10, you owe them 9 more. What do you owe altogether? Negative 19, good. So negative 19 over 12. Does that go any lower? No, not anymore, nope. It's done. Okay, same thing over here. Two signs that are different, they change to subtract. The bottom number over here we're going to use is 14 when I times them. And we're subtracting them. My bottom number I'm timing by 7. So I'm times my top by 7. So negative 5 times 7 gives me my negative 35 on top. Over here, the 7 times 2. So I'm going to times my top by 2 to get a 6. Now you're going to have negative 35 subtracting 6. How big is that going to give us? Good. Negative 41 over 14. Okay? That will not reduce. Check your work. Okay, the first thing we have to do with all these ones, on every single question, first thing we're going to do is change it to impropers. So over here, 3 times 1 plus 2 gives me 5 over 3, subtracting 4 over 3. My bottoms are the same, subtract your tops, 1 over 3. Over on the right side, you're going to notice letter B. One of them doesn't look like a fraction. Can I put it into a fraction? Yes. What do you put on the bottom? A 1. Good. So now my bottom numbers need to be 5s. So what do I times that 1 by to become a 5? 2 times by 5. Good. So I'm going to times the bottom and the top by 5. So I'm going to get 35 over 5, subtracting 3 over 5. Again, subtracting because the two signs different, become a subtract. 35 subtracting 3 gives me 32 over 5, final answer. Check your work. All right, we're going to do C. We have to change both of them first. So 4 times 10, remember, forget the negative sign at first. 4 times 10 is 40, plus 7 is 47 over 10. Now we stick that negative sign back on. 2 signs in the middle that are different, turn to subtract. 5 times 4 is 20, plus 2 gives me my 22 over 4. Now you need to convert your bottom numbers. What do 4 and 10 both divide into? Well, you can multiply and get 40, but they divide into 20. Okay, a smaller number. If you use 40, it's okay. So we're going to use 20. So I need to times the bottom by 2. I'm going to times that top by 2. That's going to give me negative 94. Over here, I'm going to times it by 5. I'm going to times that top by 5. That's going to give me negative 110. Well, sorry, positive 110, but we're subtracting, yes. Okay, so now I just add my top numbers. Serious. You owe $94, you owe 110 more. How much do you owe altogether?
Only one of them has a
Right, negative 204 over 20. Now that's going to reduce. They all divide by 4. So if you divide the top and the bottom both by 4, you should get negative 51 over 5. Okay? Let's take a look at D. Only one of them has to change to improper. 7 times 5 is 35. Plus our 2 is 37 over 5. 2 signs that are different in the middle change to a subtract. And I have 5 over 6. What bottom number should I use? 30. Good. I'm going to times them together and get 30. So let's just erase this part here so I have room. So now I'm going to put 30 on the bottom. Okay, so we've converted our bottom numbers. Now we need to multiply our tops. I take the 5 and multiply by 6. So I'm going to take the top and multiply by 6. When I do, I'm going to get 222. On the right, I'm going to take my 6 and times it by 5. So I take my top and times it by 5, and I get 25. Now I'm going to subtract them. That's going to give me 197 over 30. And if you check, none of those break down. So that is our final answer. This concludes lesson 2.6, adding and subtracting fractions.